right, good morning, good evening, good afternoon, and welcome. So this is the beginning of Chapter 3, Graphing Linear Functions, Lesson 3.1, and I'm Mr. Stiger. This lesson is going to focus on, ladies and gentlemen, this chapter on identifying linear and non-linear functions, okay? We're going to start delving more deeper into some of the maybe 8th grade stuff that you learned, but start to build on top of it as we go along. Chapter 2, we really didn't do too much bell work because we were focused on trying to get a lot of the exit tickets done. In Chapter 3, ladies and gentlemen, we will start bell work again. So please answer just 2 of these questions. All right, so for these simple setups, you guys, make sure if you remember how to solve these with this. This basically would be subtract 3n from both sides. Okay, and then I'm going to add 4 to move pieces all at once. So when I do that, this would be 2n. All right, that becomes 0. And then this is 0, and that is 4. Oh, not 4, that's 12. That would be 12. Okay, then you have 2n, divide by 2, and you have n equals 6. This one right here, it would be h plus 3 equals 10. And then h plus 3 equals negative 10. And you basically just solve for h. So you subtract 3, and you have h equals 7. And then this one here, you subtract 3, and h equals negative 13. And finally, for solve for b, first thing you always want to do is, remember, get rid of the fraction. So you would multiply both sides by negative 5r. Right, so if you do that, you have negative 5rc equals a plus 2b. Then, we want to get rid of the variable that is not attached to the b. So get rid of the a by subtracting it from both sides. Okay, and then when you do that, you set up with this basically just would be negative 5rc. Sorry, my 5 looks bad. Minus a, and then it equals 2b. And then last but certainly not least, this is multiplication. The opposite of that is division. Divided by 2, and I can leave it at that. Okay, b equals negative 5rc minus a divided by 2. Remember, that's rewriting literal equations. Okay, we're going to want to do that and be able to do a standard order of operations. Pretty simple. Look for and express regulatory in repeating reasoning. Okay, we're going to be mathematical practice 8. We're going to start about modeling functions between 2 quantities and interpreting data. Okay, you guys have been able to represent relationships amongst quantities in using equations. Now we're going to identify linear equations, intercepts, and zeros. We're going to start that process, and then we're going to graph them. We will graph them in class using our calculators and Desmos. Okay. Last year, and I mentioned it in class, last year when we took the AZ Merit and a couple other high-level tests, our calculators were given to Algebra 2 and Geometry. So I want to make sure that if that happens again this year, that will be okay, and then we'll be able to use Desmos as a backup. So your vocabulary words on your notes, you'll see a couple things. Linear equation. Today, the big one is standard form. Okay, constant x-intercept and y-intercept. You guys should have learned those in the past. First thing, standard form. The standard form of an equation that we're going to be dealing with is that form. ax plus bx equals c. Okay, where a has to be greater than or 0 to where a is greater than or equal to 0, and a or b are not both 0. A, b, and c are integers, the greatest common factor of 1. So here is standard form equation, okay? And in that standard form, a is 3, b is 2, and c is 5, okay? And then it actually gives you another equation, which is right here. Okay, let me change that color. This equation is actually just x equals negative 7. And is it a standard form? Yes, it is actually. But what you're missing is you're missing some pieces. So you have the a, which remember in front of every x variable there's a 1. You don't have a b, because there's no y coordinate, and then it does equal -7, so you do have a c. So please be aware of that when we start to go into tests, or if it's asking you and you say, well, there is no b. Well, exactly, there's no y, so you solve from there, okay? All right, so let's get started. Determine whether 5x plus 3 equals xy plus 2 is a linear equation. Write the equation in standard form. So when we deal with this, the first thing we want to do is make sure, remember, standard form is ax plus by equals c. Okay, I know it's on your notes, at the top of your notes, but please make sure you understand and follow along with this concept. So here's the question is, can you get this particular equation into this form? The answer, ladies and gentlemen, is no, you cannot. Because of this beautiful little variable right here. And because you have that xy there, you cannot actually write this equation in standard form. Okay, so write the equation in standard form. Is it linear? It is not linear. Okay, just know that that's kind of what the answer you're looking for. Okay, is it linear? No, it is not. All right, so let's move on to this one. Determine whether 3 over 4x equals y plus 8 is a linear equation. Write the equation in standard form. So we want to try to write the standard form always, if we can, in whole numbers if possible. Okay, so if we're going to do that, the first thing we're going to want to do is actually get rid of this equation. So remember we talked about in class that you can rewrite 3/4 times x as this. Okay, it's going to equal y plus 8. So we want to get rid of this this fraction. So we're going to multiply everything in this equation by 4. Okay, 4 over 1 to be more specific. So if you multiply this by 4, then we're going to multiply this by 4. I'm just going to write it in there, and then you're going to multiply this back half here by 4. So if you multiply this by 4, cross these out, you have 3x equals 4y plus 8 times 4 is 32. Now we want to get it into the standard form, ax plus by equals c. And so we have to get this by over to this side. So remember, what type of operation is this? It's just standard, actually, subtraction, right? So we're going to subtract 4y from both sides, okay? When you do that, you're left with 32 over here, and then this becomes 3x minus 4y. Ladies and gentlemen, there is your standard equation. Ax plus, in this case, the b equals -4. So it's 3x minus 4y equals 32. All right, so what I want you guys to do is in the guided practice, please answer these. All right, on the guided practice, one thing I want to make sure you understand is we want to make this a whole number we talked about. So remember, this is y over 3. You can rewrite it like that, equals -1. So how do you get rid of this fraction? Multiply by the reciprocal. Okay, so you cross these out, y equals -3. So is that in standard form? Yes, it is. All right. Now, if I were to ask you what is the a value, you would say 0 because it doesn't exist. The b value is 1, and the c value is -3. And then, ladies and gentlemen, if you were to actually put this in a graphing calculator and graph it, this is a quadratic, so this is not linear. All right. Example 2, find the intercepts from a graph, okay? Find the x and y intercepts of the segment graph. So, x and y intercepts, hopefully you guys, by this chance, we have talked about this multiple times, okay? That this coordinate here is your y coordinates, okay? And then as you go horizontally, that is your x, okay? So, ladies and gentlemen, what would be the y-intercept? So on this one here, your y-intercept, whoops, not equals, your y-intercept, and then your x-intercept, what do they both equal? So the y is going to equal 200, and the x-intercept equals 4. Pretty simple, right? Make sure you guys can actually do these. Your turn. All right, with this one, it's relatively simple. Is there an x-intercept on this graph? The answer is no, ladies and gentlemen. There is no x-intercept. So when we had talked about before about simplifying equations, okay, this says there is an x-intercept. There actually isn't. All right, this one says same thing, x-intercept. So no x-intercept, no x-intercept. And then the y is at what? So actually this one says x-intercept is 0, and this one says no. The answer, ladies and gentlemen, is that the x-intercept is not at 0, but as a matter of fact, there is not one at all, okay? Hopefully you guys understand that process. It's not x-intercept is 0, because that means if it was 0, there would be a line somewhere along the line that would go like this, or actually, let me rephrase that. On this, ladies and gentlemen, you have a line that would cross right here at the x-intercept that would be 0, okay? All right, next. Analyze the table. Box of peanuts is poured onto the rates into bags at a rate of 4 ounces a second. Table shows the functions. You guys can read the rest. Determine the x and y intercepts of the graph function. So for me, as you guys need to do next year when you get to geometry, sometimes you just got to draw a picture, okay? So when you draw a picture and you know the x is time, so I'm going to go time. All right, now this is going to be a very rudimentary kind of like graph, okay? So just understand that as we move forward. All right, we have a nice little setup here like this. This is going to be time, all right, and then weight. All right, so when we set this up, we know we're starting at, our x-intercept is actually going to be here at 0, the x-intercept is going to be at 0, 2000. So let's say it's right about here, okay? Then if you look at 125, so we move over 125, and it's going to go down, 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 until eventually you do what? Cross right there. So what is your y-intercept? Okay, your y-intercept in this case is 2000. All right, and then what is your x-intercept? Your x-intercept when you get there is 500. Okay, so x is 500. Describe what the intercepts in the graph mean. Well, what it means is that when you started this process, okay, when you start, how many weight in peanuts did you have? You started with 2,000, right? And then after 500, what? Talks about 500 seconds, you had how many peanuts left? 0. So that's kind of what you guys need to be able to do. Huge on the AC merit that you guys can read a graph and interpret the functions of it and the x-intercepts and know what it means. Your turn. All right, driving, the table shows the function related to the distance to an amusement park in miles and the time in hours the Torres family has driven, okay? So find the x and y intercepts and describes what's happened, all right? So what they're doing, ladies and gentlemen, is if you guys, let's go x and y, okay? So they're starting, if you will have this is time, and then this is distance. All right, so what are they doing, ladies and gentlemen? They're starting at the point right here, which they're starting at 248 miles away from the theme park. All right, and for every mile, or for every hour that they drive, they're slowly getting closer. So that would be 1, 2, 3, until what happens? After 4 hours, they what? They arrive at their destination, okay? So the y-intercept would be 248, and the x-intercept would be 4, okay? The graph, using the graph these using the x and y intercept. So what we're going to learn about in here is I want to make sure you guys can solve these equations relatively simple. One thing is if you guys have your books, you can turn to page 145 where we start to talk about this particular aspect, okay? And one thing that you can do is in your book it talks about replacing some of these equations with a 0 and then solving for x or y, okay? So for example, if you write this equation out and we were to say, all right, we need 2 points, right? We need a 0, y, and then we need a x, 0. All right. So what that means is that you're going to need a 0. So you would on the graph, okay, you'd be 0 up. So you need a y, and then you need a horizontal 0. So you'd be on the line. That's your X and Y intercept. Excuse me. Your X and Y intercepts. Mouth's getting dry. So one thing you want to make sure you do is let's plug it in. Okay. So we want to find y. So how we find y? We plug in 0 for x. So if you do that, 4 times 0 minus y equals 4, right? 4 times 0 is 0, so you have negative y equals 4. And can you leave this at a negative y? No, you cannot. All right, remember, you actually have to get the negative off the function. So instead of just me telling you what to, like, just get rid of the negative, you're actually supposed to multiply both sides by -1, okay? Ooh, that was tricky. Never seen that. Multiply both sides by -1, okay? So when you do that, negative times a negative is what? Positive y, and it's going to equal -4. So our function here now is 0, -4. So if we were to have a graph, okay, we would go, now we wouldn't go anywhere, but we would plot a point down -4, right there. Okay, so there's one particular point. All right, let's work on the other one. So now we want to find the x-coordinate. So to find the x-coordinate, you plug a 0 in for y. So it'll be 4x minus 0 equals 4. Well, that's simple enough. That just cancels out. So 4x equals 4. And what type of problem is this? This is division. So you would cancel that out. It'd be x equals 1. So your point here now is 1, 0. So what you would do is you go over 1, put a spot at 0, and then, ladies and gentlemen, there are your 2 points, and you just kind of connect the dots, something like that. Okay? All right, graph this equation using X and Y intercepts. All right, ladies and gentlemen, the setup on this should be fairly simple, the same thing, okay? Set it up as 0, y, and then you want to go x, 0. And then you're just going to plug in the zeros to find the other side of the equation. All right, so on this, you put a 0 in for x, okay? So it would be -0 plus 2y equals 3. This cancels out. So then you would have 2y equals 3, divide both sides by 2, and your y is going to end up being 3 over 2. So this first point is going to be 0, 3 over 2. All right, the next point, let's change colors to orange. And the next point, we're going to plug a 0 in. So if you plug a 0 in, it's going to be -x plus 2 times 0 equals 3. So you have -x equals 3. Remember, we can't leave that negative variable there. So let's multiply it by -1. You have negatives cancel out. X equals -3. So your other point up here is going to be -3, 0. All right, graph it out, ladies and gentlemen. If you do your setup like this, okay, you'd have 0, 1.5, so it'd be something right there. And then you'd be -3, 0, so you'd have a point, -3 over 0 there. Connect the dots like that. All right, this one should be fairly simple to a certain extent, okay, same setup, all right. This one here, graph to find the y's, so remember it would be 0y, okay, and then it would be x, 0. So we're plugging in the 0 for x, right? When we do that, what do you get? Y equals -5. All right, I'm not going to do the work on that one. And then if you plug the 0 in for y, okay, then what you're actually going to get is 0 equals -x minus 5. So you got to get the x to the other side. You would add x to both sides. And you get x equals -5. So there are your 2 points, okay? What's ironic about this, ladies and gentlemen, is that when you do it, -5 0. Kind of see nice little setup here. Draw it. First point, 0, -5. Second point, -5, 0. There you go. If you guys have any questions about that, please see me in class. Okay, next, graph y equals 2x plus 2. Then state the domain and range. So now we're going to move into a graphing calculator. So what I want you guys to do at home, unless you have one, is just pull up Desmos. Okay, I already have it pulled up. Just start typing away. So it's going to be y equals 2x, and I believe it's plus 2, correct? Let me verify because my memory is bad. Hey, I got it right. So y equals 2x plus 2. Then state the domain and range. So on this one, ladies and gentlemen, when we plot it out, y equals 2x plus 2, what is the domain and range? Well, is this a linear function? Matter of fact, it is. Okay, it's just a straight linear line. Now, if I were to ask for this function, what are the x and y intercepts? That's one reason I like Desmos, is on these dots, if you click it, okay, you get your y-intercept. So your y-intercept is 0, 2. Your x-intercept is -1, 0. What is the domain and range? What I want to make sure you guys do is, starting now going forward, is that we start writing the domain and range with this notation, okay? So our domain is going to be a set of all real numbers, okay? The domain is going to be written out like this. So on your notes, please make sure you write the domain like that, the range like this. And what this is, the range is all real numbers as well, okay? So what is the domain and range, ladies and gentlemen? Negative infinity is less than x, which is less than infinity. Negative infinity is less than y, which is less than infinity. Okay, or you can say greater than. It's up to you. Okay, so know when I ask you if it's a linear equation, what is the domain and range? Ladies and gentlemen, you need to write it with this notation and even do the lines. Now, I will be the first to admit that I struggle. If I go D, let me see if I can do it. D equals, yeah, that's about as good as you're going to get with me. Okay, I struggle making this annotation very badly. I will practice on it this year to make sure I get it going. But no, domain and range, that is the annotation that you need to set it up. Okay. All right, guided practice, your turn, ladies and gentlemen. All right, do I want you to make a table for these? I do not want you to take the time to make the table because it's going to take you too long. All right, instead, what I want to make sure is that you guys actually state, graph this on the graphing calculator. Okay, so 2x minus y equals 2. If I graph that one, so let's turn this off. So it's 2x minus y equals 2, right? All right, set this up. Is this a linear function? It is. Matter of fact, your x-intercept is 1, your y-intercept is -2. Is it the domain? The domain and range of this one, ladies and gentlemen, would be all real numbers. Okay, so make sure you make the standard annotation, all right, which is negative infinity to x. Sorry, I'm horrible at that. Okay, and then the other one would be negative infinity y. Do I expect artistic work? No. Does that look great? No, not at all. Okay, so that is the setup. Now, the next one, domain and range on this one, x equals 3. If you struggle with what this represents, ladies and gentlemen, on Desmos, okay, simple enough. X equals 3. What is that? That is a vertical line. So on this particular one, okay, the domain for this function is 3. But the range is all real numbers. Wow, that was, I don't know what that is. We're all real numbers, okay? Negative, infinity, y to infinity. Okay, got it? Now, the next one, if you're struggling, again, please use a calculator, pull up Desmos. I understand some of you might look at it and say, I can't remember which one is which. So just graph it, okay? And that is what again? -2. Y equals -2. I'll be the first to admit, ladies and gentlemen, that if you struggle with some of this stuff, just please graph it. Y equals -2. This is what type of line? A horizontal line. So we know then that the range on this particular function, okay, R is going to equal -2, but the domain is all real numbers because the domain is all x values, okay? You get the drift. X, and then infinity, and finish it off, okay? One thing to make sure in class, okay, if you guys start to struggle with the domain and range, graph it and then figure it out. Look back at your examples to kind of see, okay, domain was, remember, the x values. And if you were to make a table and go all down the line, you would see on this particular one that every function would have been 3, 3, 3, 3, 3 all the way down. The range on this one is -2. Every point going horizontally is -2. This is just the beginning, ladies and gentlemen. It'll get much harder. This was kind of a simple lesson. We hopefully blew through it really quick in class and possibly even started lesson 3 too. In the meantime, ladies and gentlemen, make sure you do the homework. It'll be in the comment section below. In the meantime, have a great day, afternoon, or evening, and I'll see you in class soon.